Okay, my last trig substitution video got a little crazy and a little lengthy, and I really didn't want it to be that way. I wanted it to be a learning video, but it might have been a little fast-paced. So let's just do a simpler substitution, and right here, you know, let's just assume there's nothing we can do. You know, a U substitution won't work. We could try a couple of things. So let's try a trig substitution. So we got to figure out which trig substitution are we going to use. And it looks like, in this case, A is equal to 3, and X, well, X is just equal to X, but we'll get to that, okay? So we have our A plus situation. So A plus gives us that tangent, okay? So X is going to be equal to A tangent theta, okay? But in this case, let's see, A is 3, isn't it? So it's going to be 3 tangent theta, okay? Now, furthermore, X is squared. So we need to remember that X squared is equal to 9 tangent squared theta, okay? You see that? Because it's when we make our substitution, just, you know, trust me. Alright, next thing we do, just like U substitution, we need to find dx, which is just 3 secant squared theta. Okay? So, here's our pieces that we really need to solve this thing. We need that, and we need that. Okay? So let's just bring them down and see if we can't, first of all, we can just rewrite this integral down here. Okay, so let's just do that. That is just 1 over, I'm just going to write the 3 squared as 9. And x squared, well, that's just right here, so it's 9 tangent squared theta. Now dx is equal to 3 secant squared theta, so that is 3. So better extend that a little bit. D theta. Actually, this looks kind of weird, but it's okay. Okay, so everyone sees what I did. I just sees what I did. Oh my god. Okay, x squared was equal to this, you know. It's just like U substitution, you know, and we found our dx. Okay, so let's clean this up a little bit. Let's clean this up. So, this is going to be 3 secant squared theta times d theta. That's divided by, I'm going to factor the 9 out. I'm going to factor the 9 out. And notice how this crosses out to 1/3. Okay, that's just 1/3. So I'm going to pull that constant out of here. And another thing to notice is that 1 plus tangent squared theta is equal to secant squared theta. Okay, so what do we end up with? You know, we pretty much end up with 1/3 over secant squared theta over secant squared theta, which is just 1 d theta. Okay, so that's pretty simple. So it looks like our answer is theta over 3 plus c. Okay? Now comes the part where we got to put this back in terms of t. Or no, I'm sorry, it was x. Okay? And we're going to need a couple pieces of information. Okay, first of all, we need that theta over 3 business being our general antiderivative. I just wrote that up there. And I also need to remember that a was equal to 3 and x was equal to 3 tangent theta. Okay, so here we go. I just found our antiderivative, and we're just going to go backwards from our substitution that we did earlier. And we're going to draw a triangle. So if x is equal to 3 tangent, then tangent is equal to x over 3, right? So that means opposite over adjacent. So now a squared plus b squared equals c squared. So that's going to be what? Square root of, this is going to be square root of 9 plus x squared. That's kind of sloppy. Maybe I'll write it over here. Okay, so that's what that is worth. So let's see here. So theta is equal to the inverse tangent of x over 3 plus c. Okay, so we can go ahead and say that our antiderivative, right up here, I'm going to rewrite this over here, that's going to be 1/3 plus c. Alright, so that's the answer right there. So it looks like I got enough time to go ahead and differentiate this thing. So let's do that. So d dx, okay, well that's going to be equal to we'll just throw the 1/3 out there. Tangent takes the form of 1 over 1 plus u times du, right? Remember, that's just the derivative of tangent formula. Okay, so let's just do that. So we got down here, we have 1 over 1 plus, it looks like x squared over 9, right? Times the derivative of the inside. Okay, which, let's see, that's just going to be 1/3. So we multiply this whole thing by 1/3. Okay, it looks kind of weird, but this is going to actually be 1/9, I believe. Yeah, so that's going to be 1/9. And if we get a common denominator here, okay, then we can add these together pretty nicely. Over 9. Okay, and that's just going to equal 1/9 times 9 over 9 plus x squared. And yes, they will cancel out, and that gives us 1 over 9 plus x squared. So it does check out. It looks like I got through it without screwing it up. And hopefully I didn't confuse anyone. So I'm not trying to, the papers, it gets crazy, and with all this stuff on here, I just wish I had more room to write. So there it is, okay? Any questions, send me a message, drop me a line, and I will do some videos, do some more of them, right? But in the meantime, I appreciate you watching.